To Honors Geometry. Today we're going to be talking about Learning Target 1.1. I can interpret a diagram involving points, segments, lines, rays, and angles. So as we work through today, these learning targets will be extremely important for you guys. These learning targets are what we're going to be covering on the test, so just make sure that you guys are learning all of these. That's the best way that you'll be successful in this class. So as we look at this, we're going to be looking at diagrams, and we're going to actually be creating some diagrams throughout today's notes. These terms, points, segments, lines, rays, and angles, these are all things that we're going to be going through today. These are all extremely important for this class, and we'll be using them throughout the entire year. So make sure that you know how to label these, make sure that you know how to write them down when we're just talking about point A or point B, things like of that nature. You'll need to make sure that you know how to write all of these down, know how to draw them, and know how to relate them to one another, especially in diagrams. If you can do that, then you're going to be good to go. So by the end of today, you'll be able to identify those terms. You'll know what each of them mean, what they look like, what they're made up of. Just keep track of facts about these terms. If you do that, then you're going to be good to go. And of course, how you write them out. So today's key terms that you guys need to know: points, planes, lines, line segments, rays, angles, obtuse angles, acute angles, right angles, straight angles, intersections, and unions. So we're going to be going through each of these today. I'm going to go ahead and show you guys examples of what they look like, how they're made up, all those types of things. And then at the end of today's lesson, you're actually going to have some flashcards available to you as well. They should be available in Schoology right now if you look under Student Resources. So underneath Student Resources, you'll be able to find all of these flashcards that will be able to help you guys out. It's the must-read one for 1.1. So if you do go into that must-read folder, the additional resources, student resources, stuff like that, that's where you're going to find all those flashcards for these. So make sure that you guys check that out. That's going to be extremely useful for you guys throughout this entire lesson, and just knowing these is extremely important for this class. If I'm talking about a plane and you have no idea what a plane is, you're thinking like a plane that flies in the sky, you're not going to be on the same page as me, and you're not going to really make that connection with the mathematics. So very important that you guys know the mathematical terms for each of these. You should be able to look these up all on your own as well. They should have been in your summer packet as well, so you guys should be able to get all these. And of course, we're going to be taking notes on them today, so make sure that you guys are writing down these notes. Extremely important that you guys are writing down your own notes in this class, because if you do not, then it will start showing up as you're going through these problems and it's not making sense to you. So make sure that you guys are taking your notes. All right, let's get started. First off, write each definition and draw an example. Think about where you would see these throughout your life. So I want you guys thinking about where you would see these things in real life, where you can use them, where you can find them, things like that. Of course, pause the video at any time. I'm going to have very distinct pause sections in this, but pause the video if you ever need to write down these definitions, and take your time doing that. You can always replay back if you need to as well. So first off, a point. A point is a specific location which has no dimension and is labeled by a dot. So use capital letters to name points. So for instance, we have point A, B, C, D, and E right here in this picture. If I want to write out point A, it would be point with a capital P and then A. I can also say point B, so on and so forth. But I'm always going to write out the word point prior to actually naming the point. So it must always be written out as point A. So that's how you guys are going to be naming points. Always capital letters to name points. It will never be lowercase either. Now, if I want to think about where I can see a point in real life, so go ahead and think about it for a minute. Pause the video if you need to. But when I think of a point in real life, I think about when I'm looking at GPS. So if I'm on Google Maps or Apple Maps or whatever I may be on, and I need to find a location, it will often give me the location as a point on the map. So points are very similar to locations. They're just a specific location found somewhere. Next, a plane. Now, this isn't a plane that we fly through the air. This is a plane in terms of geometry. So a plane is a flat surface that has no thickness and extends in all directions forever. We name planes based upon the points that lie on the plane. So, with planes, oftentimes what I like to think of a plane as is it's just a sheet of paper. So if I imagine this as a sheet of paper that continues on in all these directions forever and ever, it continues forever, it's just flat, That's what a plane is. It's often used in more spatial terms, so when you're thinking inside your mind, that's when you can really determine what a plane is. But if you need something in terms of the real world with planes, think of it as like a sheet of paper with no thickness, a wall, things of that nature, things that aren't going in 3 dimensions but are just a flat surface. That's what a plane is. Now, if I'm going to name a plane, I'm going to need to have 3 letters for it. So for instance, this plane that is shown, right here, this would be plane, and then I need 3 points that are on that plane. So if I look for the points on here, we have X, Y, and Z. So this would be plane X, Y, Z. Now, I can also name this another way. If there's a little fancy letter down there, that R, that is talking about the plane. So I can also call this plane R, and I'm going to use that fancy R there. So I can use it if this isn't really a point here. As we can tell, there's no actual point. It's just on the plane itself, so I can also call it plane R. So I either need 3 points to create a plane, or I need that fancy little letter right in the corner. That's another way that we can name planes. I would typically say that you should default to naming it with 3 letters. That would be the easiest throughout this course, and that's what you'll typically do. We won't very often see this, but just know that it is there, and we can relate to that down the road as well. All right, the last definition on this slide is a line. A line is a connected straight path of points that has no thickness and continues forever in both directions. We name lines based upon the points that lie on the line. So we've all seen lines before. We drew them a lot in Algebra 1. In geometry, the way that we think of lines is that if I were to take all these points, A, B, C, D, and E, all those points up there, and I were to put them right next to each other, so A, B, C, D, and E, right there, then it's just all those points. All those points can create a line. Now, lines are made up of points, so it's just an infinite amount of points because, again, it continues forever in both directions. So it's an infinite amount of points that create a line. So there's all these points on here that make up this line. So all these points will create that line that goes on forever. That also is the reason it has no thickness. Because, again, points don't have any dimension. So therefore, a line will have no thickness as a result. So it's just a straight path of points that create a line. Now, naming a line, there's a couple ways to do this. When I name a line, I should always try and default to having 2 points. So on this one, I have A and B. I'm going to go ahead and switch colors real quick. Let's go green. We have points A and B here. So I would go ahead and start naming this by drawing a line over the top. And then I just label the 2 points that make up that line. And I only need 2 points here. I don't need 3. So only 2 points. So this would be line A, B. I can also name it line BA. So again, it doesn't matter which order I go in for lines. It will matter for rays and things of that nature in just a bit. But for right now, with lines, the order does not matter in which I write it. It could be line AB, line BA, or we see this little letter out here, this cursive letter, that's also talking about this line. So we can also name it line L, or I can just write it out as line L, or line AB, or line BA if you'd like. But all of those work. So you can name lines in many different ways. Just make sure that you have at least 2 points. That will be the most common way that you guys will be naming these, 2 points on the line. But you can still name it as the cursive letter on the outside of the line if you'd like. However, you're going to see this a lot more. So just keep that in mind. Try and name lines with 2 letters, and then just draw a line over the top. All right, let's keep moving. Next up, we have line segments. So these are also known as segments. So sometimes I don't even say line segment, I just say segment. So also known as segments, they are a piece of a line. So lastly, we had a whole line that continues forever. A line segment is if I just took the distance, all the points between A and B, that would be a segment. It has an ending and a beginning. Lines do not have that. However, line segments have a beginning, a definite beginning, and a definite end. And those are both marked by endpoints. So, When I want to name a segment, I can start with either endpoint. It does not matter. So it's going to be the same type of thing as the line before. So I draw a segment over the top. Now again, a segment does not have arrows, it has endpoints, so I just draw a segment over the top. And I take my 2 points that create the segment. So in this case, it would be RS. Is there another way that I can name this? Yeah, definitely. We can also name this segment SR. So again, either way, this will work. Now if I had a cursive letter on the outside here, I could probably name it that. If it had arrows going on, it would no longer be a line segment anymore, but it would turn into a line. So line segments very distinctive because they have those 2 endpoints on either side. Next up, rays. These ones are very important when you're naming them. If you're not careful when naming a ray, you will get it wrong. So rays are similar to lines and line segments. They're made up of points. So again, it's made up of all these points that create this straight line. Very much like a line, very much like a line segment. However, the big difference here, a ray has a beginning that must start with an endpoint, and then it will extend forever in one direction. So it's not going both directions forever, it's just going in one direction forever. It'll always continue in that one direction forever. Think about it as light waves coming from the sun. Light waves will go in one direction forever until they reach whatever they are reflecting off of. So these are very similar in that regard. They continue in one direction forever. Now, naming these. Naming these is very different from the last ones. When naming a ray, you must always start with the endpoint. So, if I do not start with the endpoint here, it's saying that my ray is going in a different direction. I always must start with the endpoint because that's where we're starting our ray from, and then we say where our ray is going to. So in this case, I go ahead and I draw my ray over the top, and I'm going to label it as ray AB. So again, I start with my endpoint because that's where we're beginning, and I'm saying that my ray goes in the direction of B. So it starts at A, goes in the direction of B. Very important, people will oftentimes get this mixed up and say it's ray BA instead of ray AB. So you need to be careful when you're naming your ray. Start with the endpoint, go towards the direction that we're going. And that's the same exact way that you name it. So be very cautious on naming rays. That's the big one that many people make mistakes on. So just be wary. All right. Next up, angles. Angles are extremely important in this class. We'll be dealing with angles until the very end. So this entire year, get used to angles. People often mess up naming angles as well. So we need to be very careful of that as well. I don't want you guys to make mistakes on this because it happens very commonly. So, first off, names of angles. Again, very, very key for us. So make sure that you guys know this. Very key. So for this one, we're going to start with right over here. So this angle right here just has a number right in the center. So I can just say that that is angle 3. So if it just has something right in the center, it's not naming any points on either of these rays, then we're good to go. Now, I don't think I went through the definition yet. So an angle is a union of 2 rays that share the same endpoint. So if I look at this first one, they both share this endpoint here, both these rays, and then one goes in the direction of this blue line, or this blue ray, rather, and the other goes in the direction of this green ray. So as we can see, there's 2 different rays here, the blue ray and the green ray, and they both share that common endpoint, that red dot there, that red point. So that's what an angle is. So please be wary of that. It's always going to be made up of at least 2 different rays. Now, could there be more? Yes, but then we start naming it in different ways as well. So this first one, if there's no points on either ray or the endpoint, then we can just name it as whatever is inside the center there, angle 3. For this next one, I'm going to go ahead and draw it as a red angle. Now, as we can see, this actually has points on our angle now. So we have points A, B, and C on our angle. Now, when I'm naming an angle, my point I guess my endpoint for both rays will always be in the center. So as I can see here, A is our endpoint, so A is always going to be in the center of naming. So I'll always start on one of the rays and name it angle BAC or angle CAB. Does not matter which way I name this, as long as our endpoint is the center point here. If you name it as angle BCA, you'd be naming this blue angle here, which is not the angle that we're dealing with. So if you name these angles wrong, you're going to be talking about an entirely different angle. Extremely important that you guys have that endpoint in the center when you're naming these angles. This is the most common way that you guys will be seeing angles in this class, so make sure that you're prepared for that. All right, next up, angle D. So, as we can see here, we're just given the endpoint. We're not given any points on either rays. If that's the case, we just name it based upon the endpoint, and in this case, it's angle D. Next, the more difficult one, you guys are going to see lots of these in this class, but just be ready for it. This is the type of thing that I want you guys to know. So, we have 3 different angles here. We're going to break it down. I'm going to start with this top angle here. I'm going to go ahead and make it red. So I'll color that red right there, and then here's our red angle. And there's multiple ways to name this one. So, I can name it angle 1, which is very similar to this angle right over here. So this red one is angle 1. I can also name it based upon our second angle here. So if I were to name that, what letter goes in the middle? Well, that'd be our endpoint letter, point O. So O will go in the middle of both of these. So I can name this as angle 1, angle POY, or angle YOP. So that's for the red angle. Next, let's do the purple angle. So I'm going to make a purple angle here. And there's multiple ways to name this. Now, as we can see, this is a little bit different because I have point R and point X on here. You may be thinking, Mr. Garner, which one do I use? Do I use R or X when I'm naming this? The cool thing about angles is it does not matter which one I use. They will create the same exact ray because they're going on in the same direction forever. And they lie on the same line, so they're not going to change. It's not going to suddenly do a curve or anything. So I can name this lots of different ways. First off, I can name it angle 2. Secondly, I want to think about what letter goes in the center when I'm naming these angles, this purple angle. Well, it's always the endpoint, and our endpoint is once again O. So I can name this in a lot of different ways. I can name it YOR. I can name it YOX. Because again, their R and X are on the same line. They're collinear, meaning they're on the same line. So therefore, they will be the same exact angle. I can also name this angle ROY or angle XOY. All of these angles are the same exact thing. We're talking about the same exact thing here. So lots of different ways to name these. Make sure that your endpoint is in the center, and make sure that you're staying on the rays that create your angle. If you go off those rays, there's going to be issues there with that. So just be wary. Our last one is our blue angle. It's the big one. So here's our blue angle. Looking at this, first off, can I name it as a number like I did over here? Well, no, this big one is including 1 and 2 here. So I can't say that it's angle 1, 2, or anything like that. That is completely out. So I can't name it angle 1, angle 2. It's not possible in this regard because there's nothing dictating that it's both of them. Next, we focus on the endpoint. Again, our endpoint is point O. So all these should have O in the center. Now, as I'm working with this one, I notice that angle O is the entire thing. So this time, I can just say, oh, this is angle O, because this is all angle O is the large one. So as this says angle O here, it's very similar to angle D. I can just name it angle O, and that's fine. That's talking about the whole thing. I can also name it angle POR or POX. That doesn't matter. Again, R and X are on the same line. on the same ray, so it doesn't matter which one I use. I can use either one. I can also name this angle ROP or angle XOP. So again, all these are fine as long as O, our endpoint, is in the center of our naming. If it's not in the center of our naming, if I name this angle XPO, then that's talking about a completely different angle. So just be ready for that, guys. Make sure that you know how to name the angles. If you have questions on these, make sure that you ask me. This is one of the most important things early on in this class to know, because if we don't know how to name angles, it will get extremely confusing extremely quickly. Because I'm going to be dealing with a lot of these, and if you're thinking that ROY is the same thing as POY, it's just going to get extremely confusing. So if you guys have questions, come into office hours, write in the discussion forum of this section. Make sure that you guys get those questions answered. I want to make sure that you guys are good to go. All right, next up, types of angles. So there are quite a few different types of angles here. We have obtuse angles. Obtuse angles is an angle that is greater than 90 degrees but less than 180 degrees. So you guys probably have heard about these before. For an obtuse angle, it needs to be greater than 90. That means that it cannot be 90, but it needs to be greater than 90. So our angle X is greater than 90, but it's less than 180 degrees. So it needs to be somewhere in between here. Now, can it be 179.999 repeating forever? Yes, absolutely, this is still an obtuse angle. However, if it reaches 0.001 above that, if it reaches 180, suddenly it is no longer an obtuse angle. So very important that obtuse angles are only between 90 degrees, larger than 90 degrees, but less than 180 degrees. Acute angles. Acute angles is an angle that is between 0 and 90 degrees, so it's the smaller angles. So it needs to be greater than 0 degrees, but less than 90 degrees. Again, it cannot reach 90 degrees. It can be 89.9 repeating, and that would be an acute angle, but as soon as it hits 90, no longer in acute angle. In fact, if it's 0 degrees as well, 0 degrees would just be a straight ray. Two rays lying on top of each other. So it can't be 0 degrees either. It needs to be between 0 and 90. So that's an acute angle. Next, a right angle. Right angles is something that you guys hopefully have worked with in the past. A right angle is an angle that is exactly 90 degrees. So again, we talked about how obtuse and acute could not be 90 degrees. The reason for that is because they would turn into right angles right when they hit that 90 degrees. So it needs to be 90 degrees. Right angles are often displayed by just a box there. So all these boxes, those are just saying that that angle is 90 degrees. In fact, I don't even need to write 90 degrees. If I see a box there, I automatically know, hey, this is a 90 degree right angle for us. Very important that you get familiar with finding right angles, observing them in diagrams, and you'll be good to go. Lastly, a straight angle. A straight angle is an angle that is exactly 180 degrees. So if I have an angle that is 180 degrees, meaning that it just passed that obtuse angle and it's now 180 degrees, that is called a straight angle. Now, straight angles, those form straight lines. So as we can see, this is a straight line. And it's also formed by opposite rays. So two rays that are going in opposite directions, that is also what a straight angle is formed by. So two opposite facing rays, which would create a straight line, which also creates a straight angle, which is exactly 180 degrees. We're going to be working with straight angles a lot, right angles, obtuse, and acute. So just make sure they know all that terminology, because we'll be using it quite a bit. All right. Geometric terms. Lastly, we got triangles, unions, and intersections for our definitions. Triangles are going to be used throughout this entire first semester and somewhat into the second semester as well. Get used to triangles, very important. A triangle is made up of 3 segments. So again, segments is also another term for line segments, as its sides. At each endpoint of the segment, the triangle has angles. So as we can see, we have these endpoints here, A, B, and C. And at each endpoint of the segment, we have angles that are being created. So as we can see here, I drew little blue angles based upon where the endpoints are. Now, we name triangles based upon those angles. So to name a triangle, I always draw a triangle first, and then I label my points. So A, B, and C, those are my points that create the endpoints of my triangle. So it's always going to be named based upon the endpoints of whatever triangle you're using. Now, down the road, you'll see some triangles that have multiple triangles in them. So as we can see, we have 1, 2, and then 3, the largest triangle there. So you're going to see lots of different types of triangles. Just know that our triangles are always going to be named after the endpoints here. Now, the way that this happens is these segments, these 3 line segments, form what is called a union. So, the triangle is the union of 3 segments. The way that I think of a union is what is created when we put them together. So what is created when we put them together? Now, when I say that, I'm talking about the line segments, of course. So when I put these 3 line segments together, what is created? Well, it creates a triangle. So in the terms of a union with segments, 3 segments union together creates a triangle. That's what union will always be about, what it's creating. Now, an intersection, before I leave union symbol is a U. So that's a good way to memorize what they're talking about when you see this U sign. That means union. You're going to see this a lot more than them actually writing out union, so it's going to be looking similar to segment AB, union, segment BC, union, segment AC. So anytime that you see this U, it means union. What is being created? Next, we're talking about intersections. So an intersection is an upside down U. So as long as you remember that the U is union, you can always think of the upside down U. That's not going to be union. That leaves intersection left. So an intersection of any 2 sides of a vertex of the triangle. So what they say when they say intersection is, where do they overlap or meet? So very important. Where do they overlap or meet? Intersections and unions are extremely important in this class. Make sure that you know them. So when I say the intersection of segment AB and BC, well, if I were to, I'm just going to go ahead and draw this in purple. I outline AB, I outline BC. Do these overlap at all? Well, yes, they overlap at a single point. Where do they overlap? That would be point B. So intersection is where things overlap or where they meet. And in this case, it would be point B. If I were to find the intersection of, let's say, segment AC and segment BC, where do they overlap or meet? Well, they overlap or meet at point C. So keep that in mind. Very important that you guys get all this terminology down. And of course, if you have questions on it, make sure that you come and ask me. Make sure that you get help on it. Ask your peers. Post it in discussion questions. Anything to make sure that you guys get your questions answered. Because without this class